Today we're going to look at the standard normal distribution. But first, let's just recall a few things about any normal distribution. So a normal distribution has this bell shape, and it is centered about the mean mu. And we can label on our curve one standard deviation above the mean. That would be mu plus sigma. Or we could go 2 standard deviations above the mean, or 3 standard deviations above the mean. Over here, this would be mu plus 3 sigma. We could also label standard deviations below the mean. 1 standard deviation below the mean would be mu minus sigma. We could also do 2 standard deviations below the mean. 3 standard deviations below the mean would be mu minus 3 sigma. And we saw that for any normal distribution, the total area under the curve is always equal to 1. We also looked at the empirical rule, which said, well, it said a few things. The first thing it said was, if you go within 1 standard deviation above and below the mean, so between mu minus sigma and mu plus sigma, this is going to account for 68% of the total area under the curve. The empirical rule also says that if you go within 2 standard deviations of the mean, then you get 95% of the total area. And if you go within 3 standard deviations of the mean, you get 99.7% of the total area. Well, now let's take a look at the standard normal distribution, which has, so it's just a special normal distribution. It's still going to have a bell shape, and its mean, mu, is equal to 0, and its standard deviation, sigma, is equal to 1. And when we talk about a random variable that has the standard normal distribution, we call this random variable z. We call it z because, well, basically it represents a z-score, which we'll talk about in the next video. We also talked about it a little bit in the earlier video. But z here is our random variable. And if I were to label my curve here, if I were to label the horizontal axis, we have the mean 0 right in the middle. 1 standard deviation above the mean would just be, well, mu plus sigma would just give us 1. 2 standard deviations above the mean would be 2. 3 standard deviations above the mean would be 3. If I label my horizontal axis to the left, 1 standard deviation below the mean would be -1. 2 standard deviations below the mean is -2. And 3 standard deviations below the mean would be -3. And these same properties that hold for any normal distribution are also going to hold for the standard normal distribution. So what this means is that the area between z equals -1 and z equals +1, so that's this area here. Notice this is just 1 standard deviation on either side of the mean. So this is still going to account for 68% of the area. And well, 68% of the area, what's the area? Again, the area is just equal to 1. And so 68% of 1 would just be, well, 0.68. So here we can say the area between z equals -1 and z equals +1 is 0.68. And of course, this is approximate, right? The empirical rule is giving us approximate values. Another thing we can do is we can represent this area as also as a probability. And so here we're going to say the probability that z is between -1 and +1, right? Or the way we'd write that with an inequality is -1 is less than or equal to z, which is less than or equal to 1. And well, what this probability is saying is under the normal curve, we have all of our data items. And well, what is the probability if we were to choose a data item at random? What is the probability that it would land within this interval between -1 and +1? And well, that probability is the 68%, or 0.68. So basically, we can talk about the area under a curve, or we can talk about the probability, and they just mean the same thing. All right, so now let's see how we can find the area, or the probability, using the standard normal distribution table, right? Which in your textbook, I believe it's in the appendix on page A22 or A23. There's actually 2 tables, right? And just to give you an idea of what they look like, here's one of them. Notice that in this table, the z-values, those are on the left-hand column, and these are all negative. And basically what this table tells us is if we have our z-value, notice 0 here is in the middle, z here is negative, so it's to the left of 0, and this table gives us the area under the curve to the left of z. Right? Here's our other table, and this is for positive z-values, right? So notice here 0 is in the middle, and now z is positive. But again, the table just tells us the area to the left of z. So now, let's look at this example here. We are going to find the probability that z is less than or equal to 1.73. So if I were to just draw a picture of this, here's my normal curve. It's the standard normal curve, so 0 is in the middle. 1.73, that's maybe over here somewhere. And what we're doing is we're finding the area to the left of 1.73. That's what we mean by z is less than or equal to 1.73. And so we're going to look up in our table, and our table is going to tell us what this area is. So if we come over to our table, so 1.73, well, here's 1.7, and so our z-value that we're looking up is 1.73. So here's 1.7. In our hundreds place, we have 0.03, so that's this guy here. And if we just look to see where this column and row meet, that's going to be this value here, 0.9582. So that's the area to the left of z equals 1.73. So 0.9582. There we go. That's our area, i.e. our probability. Okay. Similarly, we can find the area to the right of 1.73, which would be the same as finding the probability that z is greater than or equal to 1.73. And so what does this picture look like? Here's 0, here's 1.73, and now we want to find this area to the right. Okay. And so there's actually two ways to do this. One way to do this is to notice, well, first of all, the total area under the curve. Remember, the total area is 1. Okay. And we actually found the area to the left, right? That's what we found up here, 0.9582. That's this area to the left of z equals 1.73. And so if we want the area to the right, well, what I'm going to do is I'm going to take the total area of 1, and I'm just going to subtract away this area to the left, 0.9582. And when we do that, that's going to leave us with the area that we want. And so we can do this calculation. This comes out to what? 1 minus 0.9582 gives us 0.0418. There we go. Let's look at another way of finding this area. So another method would be, well, first of all, notice the area that we're finding here. So here's 0, here's 1.73. This is the area we're interested in. But by the symmetry of this normal curve, I could come over here to a value of negative 1.73, and I could look at the area to the left of that, and by the symmetry of this normal curve, these areas are actually going to be the same. So if I want to find the probability that z is greater than or equal to 1.73, well, that's just going to be equivalent to the probability that z is less than or equal to negative 1.73. And now we can look this up in our table. So let's look at our table. Notice we don't want the positive z values. This time we want the negative z values. So we're looking at z equals negative 1.73. So we use the table the same way. So here's negative 0.17, and in our hundreds place we have 0.03. Where do this row and column meet? There it is, 0.0418. So that would be my answer, 0.0418. Oh, and notice that's the same thing that we got over here as well, as they should be. So either one of these methods would be fine. All right, let's try one more example. In our last example, we're going to find the area or the probability between two z values. And actually, we're going to do something kind of similar to what we set up here with the empirical rule. Remember, the empirical rule gave us an approximation, said that the area between -1 and +1 is approximately 0.68. And now we're going to see how to find a more accurate answer using our table. So let's look at this third example. So we're going to find the probability that z is between, so here's 0 in the middle, and we want z to be between -1 and +1. So finding this probability is the same as finding this area. Okay. And how are we going to find this area? Well, notice if we did, say, the probability that z is less than or equal to 1, that would be this area here to the left of 1. Okay. But what we're interested in is the area between -1 and +1. So basically, I need to get rid of this area to the left of -1. So to find this area in between, I'm going to take my total area, which is of total area under the curve for z less than 1, less than or equal to 1, and we're just going to subtract away the probability that z is less than or equal to -1. And when we do that, that's going to leave us with this area that we want. And so let's see, if we do this calculation, first of all, what is the probability that z is less than or equal to 1? We can look that up in our table. So z is equal to 1 is right here. My hundreds place is 0. So this is the area I want, 0.8413. And now we have to subtract away the probability that z is less than or equal to -1. So let's come over to our table. This time we want negative z values. So z equals -1, that's down here. My hundreds place is again 0. So we have to subtract away 0.1587. So 0.1587. And if we do this subtraction problem, we end up with 0.6826. And notice this is very close to our approximation from before of 68% or 0.68. We just get a couple of more decimal places. And in actuality, the real area is actually a irrational number that goes on forever, but this is just an approximation to 4 decimal places, which we get using our table. And there we go.